All right, welcome everyone. So let's open with something we maybe have all encountered. So let's say you needed to add a simple user preference feature, right? And suddenly you're 3 days deep in debugging dependencies across your entire front end. So what should have been a straightforward task now becomes a complex web of interconnected components, shared state, and unclear boundaries. So today we explore how domain-driven design, or DDD, can transform your front end from this tangled mess into a clean and maintainable architecture. You see some real code examples and walk away with a practical roadmap you can apply. So before we dive in, let me first quickly introduce myself. So hi everyone, I'm Marc. I've been working as a software engineer since 2013, and I'm with Space Teams from Hamburg, Germany. At Space Teams, we of course have our favorite technologies we like to work with, but we don't set ourselves any boundaries there, so we're basically technology agnostics. And to always stay up to date and dive into new technologies, we have one dedicated day in the week where we do just this, and we call it Space Time. So here's our journey for the next 30 minutes, and you can think of it as kind of a transformation story. So first, we look at real code that's getting kind of out of control, and we'll identify the warning signs that tell us something needs to change here. Then we'll cover the DDD core concepts you actually need for this transformation. And this will be no theory overload, just the practical essentials. And then we'll learn how to identify domain boundaries in our existing application. And this is where the magic actually happens, right? So finding the natural splits in your business logic. And finally, we'll see the step-by-step transformation in action. So some real code, real patterns, and real results you can apply. And as mentioned, by the end, you have a clear roadmap to transform your own front-end architecture. So let's start with a problem we may all have encountered. So yeah, let me tell you a story that probably sounds familiar. So you're a front-end developer, and your PM comes to you with what sounds like a simple request. So hey, can you add a quick toggle so users can turn off auto confirmation emails? Should be easy, right? And then you open the code base and find this user dashboard component you see here. And at first glance, it looks reasonable, right? But if you look closer at the user type here, you see in there we have 3 completely different business concerns all mixed together. So we have some profile information here managed by the profile team. We have an order history and some addresses managed by the orders team, and field notification preferences managed by the preferences team. And here's where it gets painful. So you see we have this single user state object, right? And this contains data from all 3 domains. And look what happens when someone cancels an order, right? So this handle order cancel function is called. In this case, the orders team has to update the entire user object just to change the order status. So what started as a notification toggle now requires you to understand how profile updates work, how order cancellation affects the user state, and how preferences interact with the other domains. So you see we have 3 different teams all touching the same files, right? This means the orders team can't deploy independently because they might break the profile team's code, for example. And this has some real consequences. So, for example, merge conflicts could become daily occurrences, right? Any small change requires testing the entire dashboard. And new developers need weeks to understand all 3 domains just to make simple changes, right? And what we're seeing here is also a violation of the single responsibility principle, because our component here has multiple reasons to change instead of just one. So it changes when the profile logic changes, it changes when the orders logic changes, and it changes when the preferences logic changes, right? And this creates a tight coupling between completely unrelated business concerns. And this is what happens when we organize our code by technical layers instead of business domains. So let's see what other costs this create. So if you remember our notification toggle story, well, on this slide here, these are the costs this architecture creates. So for one, we could face boundary confusion, because if we take a look back at the user model you see here on the slide, we had addresses in there, right? And we said that they are owned by the orders team. But who really owns the addresses? So in reality, the profile team might need them for shipping information, for example, and the orders team for delivery tracking. So you see, there is no clear ownership, and this leads to constant debates and unclear responsibilities. We could also face development slowdown because, well, that simple notification toggle, it touches 3 different domains, right? So this means you can't just change preferences here because you risk breaking the profile or order functionality, right? So what should have been a 2-hour task now becomes a 2-day investigation. And we also could face some cognitive overload. So let's say a new developer joins the preferences team to work on some on notifications, right? So they must first understand the entire user model here and how orders work. Even for a simple theme change, right, they need domain knowledge from all three teams. And we could also face cross-domain corruption. So, for example, the orders team updates the user state, right? This could accidentally break the profile display, or the profile team changes the user structure, and this could break the order history, right? So you see, every change is a potential landmine here. And all these problems stem from wrong decision, which is forcing separate business concerns to share the same technical models. Fortunately, domain-driven design gives a clear solution to each of these problems. And this is because it provides a clear framework to solve every of the problems we just saw, right? So here's how DDD transforms that experience. So first, when following DDD, we get a clear domain separation, right? So instead of one monolithic user model, we create separate models. So for example, our profile domain has a profile user, our orders domain has a customer, right? And our preferences domain has a preferences user. You will see this in a bit. But now each team owns and controls their own models completely. We also achieve real team autonomy here because, let's say, the orders team needs to add an order cancellation, right? In this case, they only touch the order code, right? Or the profile team wants to add a new field, right? This has no impact on the other teams. So now our teams can develop, test, and deploy independently. And we're also reducing complexity here. Because let's say a new developer joins the preferences team, right? In this case, they only need to understand the preferences logic. So there's no more cognitive overload from unrelated business domains here. And now your notification toggle becomes a 2-hour task again. And we're also using some shared language here. Because now our code organization mirrors our business organization. So when the business talks about user preferences, for example, there's a preference user model, right? Or when they talk about order management, there are order and customer models. So DDD organizes our code around business capabilities and not technical layers. So before we jump into implementation, let's first understand the core concepts that make this possible, so the DDD fundamentals. So to solve our user dashboard problem, we actually need 4 core DDD concepts. And these are the building blocks for everything we'll implement just in a bit. So the first thing is the domain itself, right? So a domain is simply a specific area of business functionality. So the profile domain, for example, handles user identity. The orders domain handles purchases, and the preferences domain handles settings. Each domain has its own business purpose and rules. And then we have bounded contexts. And a bounded context creates clear boundaries where a specific domain model applies. So inside the profile bounded context, for example, we only care about profile-related data and logic. Each bounded context can evolve independently. And then, of course, we have a domain model. And this is the actual code representation of concepts within each domain. So instead of this one user model, we now have a profile user, customer, and preferences user models, right? Each of these models contains only the data and behavior relevant to its domain. And this is what we're implementing in our example just in a bit. And then we have ubiquitous language. And this means that business and technical teams speak the same language within each domain. And the code uses exactly the same terms that business people use, right? And this also, of course, means that like if Norwegian should be your domain language, you will find Norwegian terms in your code base, right? And then you end up with a funny mix of English and Norwegian in your code. So yeah, so now let's see how these concepts look in practice, starting with how bounded contexts create clear separation. So if you remember our nightmare dashboard with the mix-up user model, well, here's how bounded contexts solve the problem completely. So you see, instead of one problematic user model, we now have 3 separate bounded contexts, as you can see on the slide here, each with its own space and rules, right? So at the top here, we have the profile bounded context. And this focuses purely on identity and personal information. And in here, you can see we have a user model, right? And here, user means someone with like an avatar and profile data. And the profile team owns this bounded context completely. And you notice these 2 markings here, they say upstream, right? And this means that the profile is the source of truth for user identity here. And being upstream means that the profile can make decisions independently, right? So when someone updates their name or email, the profile decides how and when. And the downstream context, so in our case, orders and preferences, they must adapt to these changes. Now, on the bottom left here, you see the orders bounded context. And the orders bounded context cares about purchases and shipping. Here, the same person is called a customer, right? Not a user, because that's how the business thinks about them. Well, the orders team owns this model and can evolve it independently, but orders depend on profile for basic identity information. And on the bottom right here, we have the preferences bounded context, which focuses on user settings and personalization. They have their own user model, as you can see, with only preference-related data in this case. And the preferences team can work without knowing anything about orders or profiles here. But they also depend on profile for knowing who the user actually is. And here's the problem. Because profile uses a user with like an avatar and bio, right? But the orders team needs a customer, right? With like an order history. So this means the orders can't just import the profile's user model because this would create a coupling again here. And this is where these blue ACL circles you see here come into play. These are our anti-corruption layers, our protective barriers. And they translate the profile's user concept into what each domain actually needs. So the orders ACL, for example, takes the profile data and creates a customer model. And the preferences ACL creates their own user model with only preference-related data. So now our notification toggle becomes simple again, right? Because the preferences team only touches preferences code. And the ACL handles any profile data they need. So now each team can evolve their models independently, protected by their ACLs. And this separation here is powered by ubiquitous language. So let's see how the same concept gets different names in different contexts. So, as mentioned, ubiquitous language means that business and tech teams speak the same language within each domain. So there's no more translation needed between business speak and tech speak. And as mentioned, the terms become the actual code, right? So if you remember the confusing user model, here's how ubiquitous language eliminates that chaos. You see, the profile team talks about users, right? With like avatars. So in our code, we have a profile user model. And by the way, I've chosen the name profile user here to better differentiate between the user model and the profile bounded context and the preference bounded context. So in reality, you would simply call it user model, right? But let's stick with the term profile user here. So we have this profile user class, and this could have a method update avatar, for example. So you see the business terms directly reflected in our code. And the orders team talks about customers, right? Who place orders, so they could have like a customer class with a method like add shipping address. And again, the business terms directly reflected in the code, right? So, and while the preferences team talks about users for settings, right? So same word, different context. So now, when the business says user preferences, developers know exactly which domain to change. So now, let's discover how to identify these boundaries. So, how would we have identified the profile orders and preferences boundaries in our dashboard example? Well, here are the practical signs to look out for. So for one, different stakeholders. So you see, profile features get requirements from HR and identity teams, for example. Orders features come from sales and fulfillment teams. And preferences features are driven, by example, by UX and customer support. So we have different people caring about different parts. That's a natural domain boundary here. And then different processes. So, for example, user registration follows a completely different workflow than order processing, right? And theme changes could happen instantly, but order cancellation needs approval workflows, right? So we have different business rules. This means we have different domains. And then different terminology. So marketing, for example, talks about users, right? Sales talks about customers. And support could talk, for example, about accounts. It's the same person, but 3 different business perspectives, right? So, and when the same word means different things, we have a domain boundary. And then different change cycles. So preferences, for example, change every sprint based on user feedback, right? On the other hand, the profile data structure stays stable for months. And the orders logic could change with business seasons and regulations. So different rates of change, this means we have separate concerns here, right? And well, in our example, we see all these signs. So we have different teams, different processes, different terminology, and different change rates. And as a pro tip for large organizations, there are formal techniques out there for domain discovery, like, for example, event storming or domain storytelling, and of course, stakeholder interviews. I won't go into any detail on them here because each of these techniques would be a talk on its own. But these practical indicators you see on the slide here, these are sufficient for most front-end teams to get started. So now let's see how to apply these discoveries directly to our front-end architecture. So before we take a look at the folder structure you see here, let's first address a crucial misconception. You see, the front-end doesn't create its own domains, right? This might be one of the biggest misunderstandings about applying DDD to the front end. So you see, profile orders and preferences aren't something like separate UI sections or UI domains. They are business domains reflected in our front-end architecture. So this means that each domain spans the full stack, right? So from database to API endpoints to UI components. And now, if you remember the user dashboard nightmare, right? The first step to fixing it is simple. We need to stop organizing by technical layers, so creating folders like for components, hook, or utilities, and start organizing by business domains. So if you take a look at the folder structure here, it tells the business story immediately, right? So you see we created subfolders for our different domains here. So the profile team, for example, owns everything inside the profile folder, right? The orders team owns everything in the orders folder, and the preferences team owns everything inside the preferences folder. So there's no more hunting through generic component folders here. And you notice each of these domains include the UI components, right? As well as repositories, types, and API endpoints. So the profile team owns both the profile section component as well as the API/profile endpoints, right? So you see this is a complete vertical slice here, not just front-end code. And you see we have these two ACL folders here, right? For our anti-corruption layers. So these folders protect our domains from each other, right? The profile doesn't need one in this case here because we said it's upstream, right? So we don't have it there. But orders and preferences need ACLs to stay independent when the profile changes. So now each team can work independently in their domain folder. So the profile team could ship avatar improvements, for example. The orders team could add filtering, and the preferences team could iterate on settings, right? All without coordination meetings between the different teams here. And well, our notification toggle problem, well, now the preferences team knows exactly where to go, right? Which is the preferences folder here, and they're done, right? So a 2-hour task as it should be. So now that we have clear business boundaries, let's create domain-specific models that replace our problematic user model. And well, you remember our monolithic user model, right? That caused all this chaos. Well, step 2 here is replacing it with domain-specific models. So here you see our profile domain gets the profile user, or in reality you would call it simply user, right? And this has identity information like bio, avatar, or email. And this is what the profile business domain actually cares about, right? And we also see ubiquitous language in action here because the profile team talks about users, and this is why it's called profile user here. So the orders domain gets this highlighted customer you see here, and right below this, the order model. Let's stick to the customer model here. So you see that's the same person, but a different perspective, right? And as you see, it only contains the display name here because orders doesn't care about like a bio or avatar. And this domain model here is focused on orders business logic only. So, and also, well, the orders team talks about customers and not users, right? And this is why it's called customer. And on the right here, you see the preferences domain gets their own user model, right? This focuses on settings, themes, and notifications. And well, this solves our notification toggle problem because now we have clean and focused models, right? So you see we have the same person, but 3 different business views. So there's no more mixing of concerns here. And it's important to note that this doesn't mean that we have like 3 separate tables in our database, right? We still have this one user table in our database. So you can think about these different models here as different projections of the same underlying data, where each domain selects only what it needs from this shared data, right? So now let's say the profile team changes the bio field. Well, orders and preferences teams are unaffected by this, right? So you see each domain evolves independently, and there's no more cross-domain data corruption here. So now these domain models need some data. Let's create repositories that respect domain boundaries. Well, yeah, as mentioned, our domain models need data, right? But well, we can't just call any generic API here. So in step 3, we're now creating repositories that respect domain boundaries. So up here, you see the profile repository. And this only knows about profile user objects, right? And as you can see, right below the function header here, we're fetching from API/profile, so from this endpoint, right? And not any generic user endpoint here. So this repository pattern here, well, this is basically the repository pattern in action, right? So it's a clean interface, and the profile team owns it completely, and it focuses only on the profile domain here, right? And even our backend API, you see down here, by the way, taken from an Next.js application here, even this backend API respects domain boundaries. So because if you take a look at the select statement in there, we're only selecting profile fields, right? So next to ID, we have name, email, bio, and avatar URL. And this is the bounded context enforced from database to frontend. So now the profile team can change their data needs independently. So let's say they want to add a new field. Well, in this case, they change the repository and API endpoint, right? Auditor preferences teams are completely unaffected by this. And let's talk about an important distinction between repository and ACL. So you see the repositories handle the data access within the domain, right? And the ACL translates between the different domains. So there's a clear separation of concerns here, right? And now, if you remember our user dashboard, fetching everything at once, well, now each domain fetches exactly what it needs, when it needs it. So, but what happens when the orders domain needs some profile information? Well, that's where our anti-corruption layer comes in. So, and here's where the magic happens, right? So your orders domain needs some profile information, but we can't break our boundaries. So in step 4, let's create our anti-corruption layer. And you can see this up here. So this is our ACL function, which is our protective barrier. And as you see, it translates the profile's user concept into the order's customer concept. And you notice the translation here. So the profile's name becomes the order's display name, right? So just a simple mapping in this case here. But this is basically our anti-corruption layer protecting our domain integrity. And if we take a look at the repository flow down here, you see first we're getting the profile user from the profile repository, right? Then our ACL translates this profile user into a customer, and then we use this customer to fetch orders. So a clean separation here and no mixing of domain concepts. And coming back to this distinction between repository and ACL, we see they serve completely different purposes, right? So because, again, the repository is for data access within a domain, like our orders fetching orders, right? And the ACL translates between domains, like profile user to customer. So now let's say the profile team wants to rename the field name to full name. Well, that's actually no problem, because only our ACL needs updating here, right? So display name would now be user.fullname instead of user.name. So you see the orders team is completely protected from the profile team's changes here. And if you remember our user dashboard, where changing one thing broke everything, well, now the orders evolve independently, right? Protected by their ACL. So this means profile changes don't cascade into some order chaos here. So now that we have clean data and boundaries, it's time to build domain-specific components that use this architecture. And, well, if you remember the nightmare user dashboard component, right, that handled everything, well, here we're creating domain-specific components and composing them back together in our new dashboard component. So on the left here, you see 2 examples. So on the upper left, we have the profile section component of the profile domain, and this only knows the profile user, right? And as you can see right below the function header here, when fetching this user, we're calling this get profile user current, right? And this gives us the profile user. And right below this, the order section component of the orders domain, this never mentions profile user, right? Right below the function header, as you can see, we're calling this get orders for current user, where the repository and the ACL handle all complexity behind the scenes. So this means the order section gets user data but never touches profile code, right? Because the ACL translates the profile user into a customer behind the scenes for us, as we saw on the previous slides. So this means this component here stays pure and focused only on orders business logic. And here is our beautiful finally, right? This is our new dashboard component. As you can see, it's simply a composition of the different components of the different domains, like our profile section, order section, and preferences section. And this preferences section now finally contains our notification toggle. And if you take a look at the import statement, so right below right at the top of this highlighted yellow box here, right, you can see how each component comes from its own domain, right? And well, now our original nightmare. Well, before adding notification toggle was a 2-day or 3-day debugging session across, let's say, 200 plus lines of mixed code, right? Now we're just going to the preferences folder, update our preferences section, and we're done, basically. So 2 hours as it should be. So now let's say the profile team deploys avatar changes. The other teams are unaffected by this, right? Or the orders team adds filtering. Profile doesn't care. So now each team can develop, test, and deploy independently. And this is true team autonomy achieved here. And from a user's perspective, well, it's the same seamless dashboard, right? But from a developer's perspective, this is a complete transformation from chaos to clarity. So there's no more giant shared user object passed around here, right? You see, each component manages its own data through its own repositories, right? So we've now seen all 5 steps of this transformation here. Let's summarize what we've achieved and the key principles to take away. So first, this has some real business impact here. For one, we get a faster feature delivery, right? And we are reducing bugs through this clear separation of our domains and our code, right? We're also seeing happier developers, and most importantly now, your architecture reflects how your business actually works. So you don't need to transform your entire application overnight here. Here's the practical roadmap. So first, think business and not technology. So stop organizing or creating technical folders like components or utilities, right? And start organizing by business capabilities. So create subfolders for your different domains, like profile, orders, and preferences, and ask yourself, would a business person understand your folder structure here? Then spot the warning signs. So if you remember our notification toggle nightmare, well, that's your early warning signal here, right? If simple changes require understanding multiple business domains, you need DDD. And if teams are afraid to deploy, your boundaries are broken. Then build protective boundaries. So create domain-specific models and use repositories for data access within these domains and ACLs to protect domains from each other's changes. This approach helps you build maintainable and scalable applications. And then start small and think big. So find your most painful component first, basically your user dashboard equivalent, right? Then extract one domain from that first, get that working, and then you can extract the next one. Each extracted domain makes the next one easier. So next time you're at work, open your biggest and most complex component and ask yourself, how many different business concerns is this handling? And write them down. And that's it. You've just taken your first step toward domain-driven design here. So you see, your architecture should always tell your business story. When it does, everything becomes easier. From development, testing, scaling, and most importantly now, finally adding that damn notification toggle, right? And well, with this, thank you very much.